Okay, so let's solve exact same problem, but now we are going to apply instantaneous center approach. So this is the definition of the instantaneous center. So the point O about which all velocities appear as tangential velocities is called the instantaneous center of rotation and has a zero velocity. So this is the point in space, and if we sit at this point and observe points like on this link, all those points will rotate around like that point at this time instant. Okay, we start in exact same way, right? We will consider links connected to the frame, so we know that velocity c. So since it's a circular slot, so that's what that cross tells us, right? So this is the usual notation of the circle center. So let's maybe a little bit edit it here. Okay, so this is going to be perpendicular to this. So this is our velocity c. We know also magnitude of this velocity. Okay, and we also know that velocity of b is pointing to the left. So that roller is moving along that horizontal surface. So the center of this roller has velocity, so which is pointing to the left. Okay, so this is good. So this is our velocity v. Okay, good. So to get that instantaneous center, so since we know that all velocities are going to be tangential, so we need to take lines perpendicular to those. Let's maybe use another color. Okay, so we take those perpendicular lines. So this is perpendicular to our velocity vc, and we also need the line perpendicular to velocity b. Okay, so now we can see that if we sit in this point, which is going to be instantaneous center, so if we throw the radius like to this point c, velocity at point c is going to be perpendicular to this radius. So let's call this radius c. And if we take point O and throw the radius to point B, so that velocity is going to be perpendicular to the radius, and this is going to be tangential velocity. And let's do this as r. Okay, so we know that if this angle is theta, right? So this angle is theta, and this angle here is also going to be theta, right? We know that cosine, so this is 3, 4, and 5. We know that cosine of this angle theta is equal to 3 over 5, right? And we also know that it is 60 divided by BC, right? And we can calculate our BC. So which is going to be 5 multiplied by 60 divided by 3. So it's 300 divided by 3, so this is 100 inches. Okay, so this is good. We will also need this angle as well, right? So let's calculate it. So tangent of angle theta is equal to 4 divided by 3. So our theta is equal to, let's calculate it. So it's 4 divided by 3. And tangent 53.1 degrees, 53.1 degrees. So this angle is 90. So that means this angle here is going to be, let's maybe distinguish like this calculation. So it's here. So this is going to be 90 minus 53.1 degree, and this is equal to 90 minus 53.1, and this is 36.9 degrees. So I'm just 36 degrees. Okay, so I'm just extracting all possible geometrical effects, and then we will discuss why this instantaneous center is important. Okay, let's draw a horizontal line here. Okay, and this angle here is going to be exact same as this one, so it's going to be 53.1 degree, and this angle is going to be this angle here, so let's call this angle alpha, let's say 5, right, because this is going to be exact same line with the same slope. Here this is 12, this is 5, so this is going to be that angle alpha, and tangent of this angle alpha, let's maybe put it here, that calculation, so tangent angle alpha is equal to 5 over 12, so our alpha is equal to 5 12, and it's 22.6, right, so 22.6 degrees. So this is 22.6. Okay, so this is good. 22.6 degrees, and altogether, so this angle here is going to be 53.1 degrees plus 22.6 degrees, right? And this is equal to 53.1 plus 22.6, 75.7, so 75.7 degrees. Okay, and we can also get this angle here. So this is 180 minus 36.9 minus 75.7, and this is equal to 180 minus 36.9 minus 75.7, 67.4. So this angle here is 67.4 degrees. Okay, so we actually have this triangle set. So we have the side, so which is 100 inches, and we have all angles known inside this triangle. So we can calculate everything else. So why we need to calculate everything else? So why we need to calculate those radiuses? Because those are tangential velocities, right? So by definition, right? So by definition, our tangential velocity, for example, velocity c, magnitude is equal to radius c multiplied by omega of bc, and velocity of b is equal to radius of b multiplied by omega bc. Okay, so what are knowns? Velocity c is known, right? And if we calculate our RC, so that's radius, we can calculate omega bc, and that's what we need. Okay. if we calculate, let's say, omega bc, and if, let's say, we need to calculate also velocity b, absolute velocity of b, so we can substitute that angular velocity which we calculate from this equation into this equation after we calculated our radius b, and we can also calculate velocity of b if we need to. Okay, so this is good. So let's calculate our RC, because that's what we need. We're going to apply sine law, and we have 100 divided by sine of 67.4, and this is equal to our RC divided by sine of 36.9. Okay, and our RC is equal to 100 multiplied by sine 36.9 degrees divided by sine of 67.4 degrees. Okay, so let's calculate this. So we have 36.9 sine multiplied 100 divided by 67.4, and that, so 65, right? So it is equal to 65, right? So 65 inches. Okay, so then here we can calculate our omega bc, and this is equal to bc divided by rc. Okay, and our vc is 36 divided by 65. See how much is that. 36 divided by 65, 0.55554 radians per second, and this is clockwise, right? So this is clockwise, right? So you can see that all that stuff is rotating clockwise, right? Okay, so as you can see, in this particular case, I would say it's a bit easier, right? So we have a little bit lighter geometry, right? A little bit less of calculations. But again, like in a whole bunch of cases, it's about the same in terms of the labor. So sometimes like this approach like is more convenient. So sometimes it introduces some simplification into calculations. But again, like in average, I would say, like in this particular set of problems on this level, it's about like the same amount of labor.